Welcome to the presentation by Joe Backus, Dresden Scheid, and Aidan Gatchell on significant figures. Section 1. About significant figures. To begin, significant figures are the digits in a measurement known for sure plus an estimated digit. In chemistry, significant figures are important because when measuring both volume and mass, for example, it is important that the measurements are exact, and doing so requires significant figures. These significant figures come from the numbers of digits in a value, often a measurement that contributes to the degree of accuracy of the number. When determining the amount of significant figures from a given number, just counting the amount of numbers does not mean it's significant. You must follow specific rules, especially when it comes to whether or not zeros count. The role of these zeros in the number varies depending on where the zero is located in the number. For instance, any zeros in the front of the number are never significant. Confined zeros that are located between non-zero digits are always significant. Trailing zeros are located at the end of a number, and they are only significant if it has a decimal point or an overbar. Some zeros are considered significant, while others aren't, because some zeros are just considered as placeholders, while others provide an actual purpose. Section 2. Rounding and counting significant figures. When it comes to significant figures in chemistry, you first need to find what you are rounding to. If the next digit is less than or equal to 5, then you drop all the digits that are after that. You then keep that digit that is before, and then you round correctly. But if the next digit is greater than and is not equal to exactly 5, then you increase that digit in the place you are rounding to by 1 and drop all other digits. When it comes to addition and subtraction of significant figures in chemistry, you assign significant figures in the answer based on the number of decimal places in each original measurement. But with multiplication and division of significant figures in chemistry, it gets a little tougher. When you multiply or divide, you assign significant figures in the answer based on the smallest number of significant figures from your original set of measurements. Section 3. Equipment. When it comes to using a graduated cylinder, fill it with your substance and place it on a level surface. When looking at the graduated cylinder, look at the measurements straight on and look at the bottom of the meniscus that is formed by your substance. Wherever that lines up with is how much the substance there is in there. On a 100 milliliter graduated cylinder, as the one pictured shows, the increments are in whole numbers, so it's nice and easy to measure accurately with whole number positions. You then add a tenth of a milliliter in order to calculate the significant figure. On a 50 milliliter graduated cylinder, again as pictured, it counts by halves. With this one, you would then, for your significant figure of the guess, you would have to find the value between a 0 and a 0.5. The same rule applies for a 25 milliliter graduated cylinder. Any graduated cylinder that measures by halves is easier to measure a substance accurately to the nearest tenth place. However, the 10 milliliter graduated cylinder counts by tenths of a milliliter. This allows for an accurate guess to the hundredths place when you're counting significant figures of a milliliter. For each photo here, the type of graduated cylinder is labeled underneath. On the far left, you have the 100 milliliter graduated cylinder. This measures the whole numbers of milliliters, such as 50, 51, 52, and so on. The next one, on the right of it, is the 50 milliliter graduated cylinder. This one measures in halves of milliliters. For example, 31.5, 32.0, then 32.5, and so forth. The same is true for the 25 milliliter graduated cylinder on the right of this one as well. However, as stated before on the previous slide, the 10 milliliter graduated cylinder counts in tenths of a milliliter, 3.4, 3.5, 3.6, and continuing. Now let's talk about properly using equipment and measuring materials. When measuring with a ruler, the ruler has two different sets of measurements on it. One side will be inches and the other side will have centimeters with millimeter increments. A typical ruler is 1 foot long, or 12 inches, and 30 centimeters long, or 300 millimeters. The inch side will have little hash marks between each inch mark. Although the amount may vary, some rulers have hash marks down to the 1/16th of an inch, while others will only read to a quarter of an inch. When measuring with a ruler, place the start of the object on the 0 mark whether in inches or centimeters. Then read where the object stops on the ruler by looking for the hash mark closest to the end of the object. To the right, you'll see a pencil next to the ruler. An accurate measurement would be 5.63 inches. To calculate significant figures, with some rulers, when it goes down to a 16th, you'd find what number matches up with the first 16th and then the second 16th. So basically, the middle of that is where you're guessing your significant figure for the guess. For measuring with a thermometer, whether it's regular or digital, there is a process to ensure that you get the correct measurement every time. When using the digital thermometer shown, you will first press the on-off button and wait until the numbers come up. Then you can either choose for it to read in Celsius or Fahrenheit. Once you have the thermometer set up, you will insert the end of the thermometer into the substance you wish to take the temperature of and wait until the number stops changing. With a regular thermometer, you just put the end of the thermometer in the substance you want to take the temperature of and wait for the mercury in the thermometer to stop going up. You will then read the number that the mercury has stopped at. Again, on the right, you will see two pictures. The one on the left is a regular thermometer that reads 22 degrees Celsius, and on the right reads currently that it is 73.5 degrees Fahrenheit, or, when converted, to 23 degrees Celsius. These are two accurate measurements. These show how there are different degrees for each liquid. To measure the mass of an object using a digital balance, you first need to turn on the balance, then look at the number the balance is showing, and if that number is not 0.0, press the 0 button on the calculator to set the balance to 0. Then, the next step can change depending on what kind of object you are weighing. If you are measuring the mass of an object that doesn't need a container to hold it, just place the object on the balance and wait for the number to stop moving and settle on a number. Sometimes it will guess between two numbers, but the one it is currently on and the most on is the one you should write down. But if you are measuring the mass of an object that must be in a container, first you must weigh the container itself and find its mass. Once you have done this, you can then place of the substance and weigh the whole thing. Once you have the mass of the whole thing, subtract the mass of the container alone, and that leaves you with the mass of the substance.
So just to add something, you can also place the container on the balance and zero the balance, then place your substance in the container to get an accurate measurement of the mass.
On the right, you see an image of a balance on the graduated cylinder on top of it. After the steps have been followed for the balance, you can find that the graduated cylinder with the water in it had a mass of 41.59 grams. This is how you mass something. Barrettes are elongated tubes made of glass that have a draining valve in the lower half and are used just for that. The valve can be twisted to let small or large amounts of liquid through. A flask or beaker is usually underneath these, which allows for collection of a liquid. Liquids are usually poured into the barrette through a funnel, oftentimes requiring a lab student to lift it up to relieve pressure. Barrettes are read differently than normal graduated cylinders. When reading them, you read from the digits on the top of the barrette to the bottom. You also read it as the number shown and then the units dispensed from the barrette, and not the number of units left in the barrette. The dispensed amount of liquid is let off into a flask through the bottom. To the right again, you will see a barrette. If the line was to say 4.5 milliliters, that would be how much is in the barrette. It would actually mean that 4.5 milliliters was dispensed from the barrette, and subtracting that from the total amount of milliliters possible would be how much was left. Erlenmeyer flasks and beakers do not have measurement marks on them, so you will not be able to accurately measure anything with them. The volume measurements on these are poor and are only used for rough estimates of substances. On the right-hand side, there are two more photos. One on the left is an Erlenmeyer flask, and the one on the right is a beaker. While the beaker shows some form of measuring, it is extremely rough and cannot be used to make precise measurements. This concludes the presentation on significant figures. Information collected was done by all. Speaking was done by Joe, editing was done by Dresden, and the main answers were done by Aiden. Thank you for listening.